Yeah. Dang it. The other person you might be able to ask is Dix. Mark Dix. He might have something. No. No, just some. What's up, Alex? Not much. Good. That's it? You have to. Hurry. You're late. No. Megan should have it. Yes, it was. We ordered it. And by the way, the bell didn't ring. That was just 7:30. So, yep.
I think it's about to ring.
No, it already should have rang 30 seconds ago.
Really?
Yep. Because it's not something. Yep. It's running late. Good morning, ladies and gentlemen. How are we doing today? Not a very lively crew on this Monday morning, you're not. Is that because it's Monday or what? Okay, good. Glad we could have these wonderful conversations in the morning. So while I'm getting attendance, ladies and gentlemen, start thinking about our question of the day. Our question of the day is, can you name me 7 ways that you can have a dollar using only one type of currency? Using only one type of currency. 7 ways that you can have a dollar. Mr. Bratton? It's sitting in there. It's sitting in my fume hood. Yep. Okay, bye. Okay. All right, ladies and gentlemen. They're only a minute and a half late. That isn't bad. Apparently the bells are having trouble on Monday mornings too, ladies and gentlemen. All right, so start thinking of 7 ways that you can have a dollar using only one type of currency. Did I ask you this question the other day? Yeah. Sorry about that. I couldn't remember if it was you guys or if it was my 5th hour. All right, we'll come up with something different then in just a minute. Hold on. 10 minutes. All right. All right, no way then. Yes. Jacqueline. Yes. All right. Okay. All right, ladies and gentlemen. In that case, ladies and gentlemen, since I already asked you this question, there is no sense me asking this to you again. But what we will do is we will get moving a little bit quicker than today. So a couple of things. I talked to the person who missed the quiz last week, Friday. If you're missing things, ladies and gentlemen, you need to get them turned in and made up. Okay. We're starting to get some assignments in. Everything that is listed over there is the things that we have done so far. Okay. So you've got 2 labs and 2 quizzes there, which means you've got 4 things that are making up your grade right now. I did grade the, no, I didn't. I'm giving you the metric conversion worksheet today. So just so you know, if you're missing something, you need to get it in. Again, if you were gone on the day of a lab activity, I put an alternating assignment in there for you, but you got to get it done and you got to get it turned in because otherwise things are not going to go very far for you. They're not going to go very well for you. The people who failed my class last trimester were people who didn't do the work. It was that simple, okay? So if you're missing things, get them turned in. I got a metric. We're going to talk about metric conversions, and I got a worksheet for you that we're going to do today. I did post a scientific notation worksheet. I'm not requiring that you do it. Scientific notation is something we don't use a lot of in here, but we will use it. And I do have a little bit of a review. If we get a chance, we will go over it. And I did take a worksheet and put it out there. But basically, it's just converting into and out of scientific notation. And if you feel like it's something you need more practice with, please feel free to do it. If it's not something that you don't, if something you don't feel you need more practice with, you do not have to do it. Okay. By the way, in Google Classroom today, I posted the answer keys for you for all of the worksheets that you will do in here. So if you go into Google Classroom here, ladies and gentlemen, Unit 1 answer keys. Would help if you were looking at it. Sorry. Unit 1 answer keys are right here, ladies and gentlemen. So when you click on it, these are the answer keys for all of the different worksheets that you will be doing in this unit. They're already there for you. The reason I do that is I do not want you taking and working on a worksheet and doing it wrong the whole time and then turn it in, and then I just look at if it's done or not. I look if it's completed. So if you are doing it wrong, this is where you're going to find out by checking the answer keys. So my suggestion is do a few problems, open up the answer keys, check and see if you're doing them right. And if you are, continue. And if you're not, ask questions or come see me, or maybe you could figure it out. But that's why I post the answer keys for you as well, ladies and gentlemen, so that you can see them and you can use them. Okay? You want to copy the answer keys off of the answers off of the answer key, put it on your worksheet and turn it in. That's fine. I don't care because, to be honest, it doesn't count for anything anyway because homework is not part of your grade. But it's probably not going to help you very much when you go take a test and I ask you the same type of problem and you can't do it. So your call, ladies and gentlemen. Okay? Questions? All right. If you would, please open up your EISN and go to the measurements. I am on slide number 28. This is where we left off last week, Friday. When the bell rang, we were about to do some conversions on here. So if you would open that up, ladies and gentlemen, that would be wonderful. Now, here's the other thing. I have scratch paper up here for you. Anytime you need it, please come up and grab some. I'm going to be working through some problems here, and I will tell you, typing them out is a pain in the butt. Okay? It really is. So, again, if you want to do these problems on paper, take a picture of the paper and put it in there. If you just want to watch and do them when we do them on the worksheet, that is 100% up to you. But I have some abilities with my pad up here that I can write in there that you cannot. So, however you want to do it, that is up to you, ladies and gentlemen. Okay? All right. So, first thing, ladies and gentlemen, when we look at this, okay, in a conversion, you have to figure out what unit you're in and what unit you are going to. So, our conversion here, ladies and gentlemen, is to go from liters to milliliters. So, I need a fact that relates milliliters and liters. And that is right down here, ladies and gentlemen. That is this one down here. 1,000 milliliters equals 1 liter. So I'm going to use that to convert from liters into milliliters. Now, our problem always begins with what we're given. We're given 0.985 liters. I am going to take this fact, 1,000 milliliters equals 1 liter, and I'm going to use it one of two ways, ladies and gentlemen. I'm going to put 1 liter over 1,000 milliliters, or I'm going to put 1,000 milliliters over 1 liter. What this is going to do, ladies and gentlemen, is this is going to allow me to convert from one unit to another. Now, also, if you're sitting there, oh, Ms. Rand, why don't you just slide the decimal a few places? Yes, you are absolutely right. We can do that with the metric system. Okay? But in later units, when our conversion is 1 mole of water equals 18.0152 grams of water, that's not sliding the decimal point anymore. Okay? So the system that I'm going to show you now is one that we will use in this class over and over and over and over again all year long. Now, granted, it is a little bit of overkill for metric conversion, but it will never fail you. In other words, if you do it right, it will work for you later on as well. Okay? So the way I'm going to decide which of these two I need, do I need liters over milliliters or milliliters over liter? It's called unit cancellation. I want to cancel the unit of liters. And the only way I can do that, ladies and gentlemen, is if liters is up here, it has to be on the bottom of the fraction that I'm about to write. So I'm going to use the one that is on the bottom over here, this one, because it has liters on the bottom. So I'm going to put 1 liter on the bottom. I'm going to put 1,000 milliliters on top. Liters and liters cancel. Now I'm multiplying by 1,000. I am just still sliding my decimal. But again, I have people ask me, Mr. Brand, do I multiply or do I divide by 1,000? Okay. The question is, which way are you going? Are you going out of milliliters and into liters, or are you going out of liters and into milliliters? That determines which one you will do. But here's what I will tell you. With this method, we take this number, which is, by the way, considered to be on top. It's not in a fraction, but if it was, we could put it over 1, correct? Okay? We take this number that's on top and we multiply it by every number that is on top. And then we divide by every number that is on the bottom. Now, do I need to ever multiply or divide by 1? No, it doesn't change anything. So you will hear me say, are we multiplying or dividing here? I'm not worried about the 1. What I'm worried about is the 1,000. So since the 1,000 is on top of the fraction, ladies and gentlemen, you're going to multiply by it. If the 1,000 were on the bottom, you would simply divide by it. Okay? So any number that is on top, you're multiplying by. Any number that is on the bottom, you are dividing by. And again, I'm ignoring ones. I hope you can see that. I hope you can understand that. Because dividing by 1 here isn't going to change anything when I'm all done. So I'm going to take 0.985. I'm going to multiply by 1,000. What do we get from that? Don't everybody jump on it all at once. 985. Now what's our unit? Milliliters. This number here and this number here mean the same amount. It's like saying 4 quarters and 10 dimes. Okay? They mean the same amount of money. They are different numbers? Yes. Why? Because they are different units as well. But they are equal to each other. They are equivalent to each other. Okay? Jen, I'm sorry you can't. If you want to take a picture with your Chromebook or that, you can, but I can't let you use your phone during class. I'm sorry. We're not allowed. We're just not doing that this year with the phones, okay? So, questions? Okay? Now, again, when we do this, ladies and gentlemen, I am not going to hold you responsible for memorizing that 1,000 milliliters equals 1 liter. I won't do that. Okay? Not going to make you memorize that. Hopefully, over time, if we use it enough throughout the course of the year, you will begin to memorize this. But on a quiz, on a test, in problems, I will give this to you. Okay? If I don't have it on the sheet, you can call me over and say, Mr. Brown, what was the relationship between milliliters and liters again? And I will put it out there for you. I will give it to you. Questions? All right. So, let's go to the one on the bottom, ladies and gentlemen. Okay? We're going to convert from 3,625 grams into kilograms. Okay? So again, ladies and gentlemen, we are going from grams to kilograms. So we have to come down to this table at the bottom. Here's grams, ladies and gentlemen. The relationship between kilograms and grams is this one right here. You've got to know what is equal to what to be able to use this, ladies and gentlemen. And again, there are 2 ways that I can write this. I can put 1,000 grams over 1 kilogram, or I can put 1 kilogram over 1,000 grams. Which one is determined by the problem? So in my problem, I have 3,625 grams. That's what I'm beginning with. I want to get to kilograms. So because grams is on top here, I need a conversion where grams is on the bottom here. That is this one. So I'm going to put 1 kilogram on top. I'm going to put 1,000 grams on the bottom here. Grams and grams will now cancel out. The unit that I'm left with here is kilograms, which is what I wanted. That's what I wanted to get into. But this time, ladies and gentlemen, because the 1,000 is on the bottom, whenever it is on the bottom, you are going to divide by it. When it's on the top, the number that is not a 1, you are multiplying by it. That's why we multiplied on the top. That's why we're dividing here in the bottom. So our number becomes 3.625 kilograms. Questions?
No.
And again, dividing by 1,000 is simply sliding the decimal 3 places to the left. Multiplying by 1,000 is sliding the decimal 3 places to the right. I understand that. I completely get that. Okay. But again, this is something that we're going to be doing in other units as well. All right. Questions? Okay. Now, here was the thing about these two problems, ladies and gentlemen. In both of these problems, we had the central unit involved. We had grams and we had liters involved. Okay? Anytime you have the central unit involved, these are one-step problems. Okay? I do not, again, I'm not expecting you to memorize all of this. And there are literally, ladies and gentlemen, millions upon millions upon millions of conversions that you could learn. Okay? I'm not expecting you to do that. Some you may already know, some you may have used, like these, okay? But for example, how many feet are in a yard? 3. How many feet are in a mile?
5,280.
5,280. How many yards are in a mile? Exactly. Exactly. Most people don't know. Okay? Most people don't know how many yards are in a mile, and that's fine. We don't expect you to. Okay? But, ladies and gentlemen, that doesn't mean we couldn't convert between the two simply by knowing how many feet are in a mile and how many feet are in a yard, as long as there's some commonality there. So again, if we're going from any of these to the central unit, it is a one-step problem. However, if we are going from one prefix unit like milli to kilo, now it becomes a two-step problem. I'm not going to give you anything that relates milli and kilo. We will relate kilo to the central. We'll relate milli to the central. I will give you nothing that relates those two units, though, with prefixes. Okay? So just so you understand, just so you know. Questions before we go to our next slide? All right. All right, so here is one, ladies and gentlemen, where we are going from centimeters or kilometers to centimeters. So now, ladies and gentlemen, we are going from a prefix unit to another prefix unit. This is going to require 2 conversions. Which 2? This one here, kilometers to meters. And this one here, centimeters to meters. So these are the 2 facts that I'm going to use. 1,000 meters equals 1 kilometer, and 100 centimeters equals 1 meter. I'm going to need to use both of these, ladies and gentlemen. I'm going to need to use both to get from the unit of kilometers into the unit of centimeters. Okay? So our problem begins with the number that we are given, writing it down.
Wait.
Go ahead.
That one, did it say 100 or 1,000?
1,000. Wait. Sorry, I interrupted you. Which one are you asking me about? The
Right.
100 centimeters equals 1 meter.
Okay, that's right.
No, sorry. Sorry, I jumped the gun there and started to answer your question before you finished it. So, because I'm in kilometers, ladies and gentlemen, I have to have a conversion that has kilometers in it. That is this one right here. That is our first one. And again, the only way I'm going to cancel kilometers is if it is on the bottom here, because the top and the bottom will cancel. So that means I'm going to put 1,000 meters on top, 1 kilometer on the bottom. The units will cancel out now. Now I'm not going to stop here because I'm not done. I'm going to set up a second conversion right away. I'm in the unit of meters now. I haven't done my math, but the only unit I'm left with is meters. So now I'm going to use this second one, ladies and gentlemen. And again, I want my units to cancel. Well, it has the unit of meters in it. That means that on the bottom here, I'm going to put 1 meter so that the unit of meters will cancel. And on the top, I'm going to put 100 centimeters. Okay. Now in your calculator, ladies and gentlemen, you are going to take this number, multiply by 1,000, multiply by 100. By the way, if you need calculators, ladies and gentlemen, come on up and grab one. There's a whole bin full of them up here. You're going to need them today. Okay? I don't want to see you having to bop back and forth on your computer to your calculator. So if you want to come up and grab one, if you've got one of your own, absolutely fine, ladies and gentlemen. But there are calculators there for you.
I'm not enjoying it. I have to do this and I'll do the two.
You're not enjoying math followed by math?
Well, it's just a lot going on this.
I feel like
I understand.
To that.
it's better.
I understand, but remember, we give math meaning in science because we talk about actual things.
Are you saying math is pointless?
What?
Are you saying
No, I'm not saying math is pointless. I'm just saying math does not have meaning like things in science do. We don't talk. These are actual things, ladies and gentlemen. Kilometers, centimeters. Okay, in math, they may just convert. Okay? By the way, I can pick on math teachers because I married one. Okay? So,
Does she like it?
no, she does not. All right, so take 0.612 times 1,000 times 100 and tell me what we get, please, ladies and gentlemen.
61,200.
61,200. And the unit is centimeters. Now also, this is the reason that we don't convert from kilometers to centimeters. Why would you take a number like 0.612 and make it into 61,200 centimeters? It doesn't make sense. It'd be like asking, how much is $50 in pennies? Okay, nobody wants $50 worth of pennies. Okay, well, I guess $50 is $50. But again,
Maybe you want 5,000.
maybe. Okay, maybe. Okay. Questions?
Oh, did you release the alternate time? I didn't get the chance to check for it.
I did put it in there, yes, for you.
Thank you. I'll do it during my.
Okay. Questions? I will assume that's a no, ladies and gentlemen. All right. Now, again, ladies and gentlemen, we can convert from any unit to any other unit. It does not matter. But I don't think we will ever, after this unit, talk about a decagram again in chemistry. A decagram is 10 times a gram. So 1 decagram is 10 grams. Now, it's a unit that, again, we would never use. We would never talk about. We can. It exists, but we would never use it. But for this problem, again, we are going to do it. Let me change. Let's go with green because it stands out more. So, milligrams, the unit here. Central unit is grams. Here's our relationship for milligrams. 1,000 milligrams equals 1 gram. That's one of the 2 relationships I'm going to need. 1,000 milligrams equals 1 gram. Okay? Now, the other one I need relates decagrams and grams. Well, here's deca, here's grams. So I'm using this one as well, ladies and gentlemen. 10 grams equals 1 decagram. Okay? Those are the 2 conversions that I will need. How do I know I only need the 2? Because if I'm in milligrams, I can get to grams. then to get to decagrams, if I were in grams, I can get to decagrams. These two connect via gram. That means that this is everything that I need to solve this problem. Okay? So, again, we write down the number we are beginning with, 4,261 milligrams. We set it up by making a conversion. Milligrams is on the bottom, ladies and gentlemen, so I need to use this one first because it involves milligrams. And in this one, because milligrams is here, milligrams needs to be on the bottom, so I'm putting the 1,000 milligrams on the bottom. Putting 1 gram on top. Milligrams and milligrams will cancel each other out. Next, ladies and gentlemen, I want to go to decagrams. So again, I've got 10 grams equals 1 decagram. Well, grams is up here, so grams need to be on the bottom here. 1 decagram on top here. Grams and grams will cancel out. When I am done, I'm going to be in decagrams. Now all I have to do is do the math. Okay. Now, here's where you need to be careful, ladies and gentlemen, with your calculators. Okay? Depending on how you punch this number into your calculator will determine if you get a right or a wrong answer. Okay? There are a bunch of different ways we can do this. Okay? I'm going to talk to you about the way that I prefer to do it. If you wish to do it another way, you can. So one of the ways you could do it is punch in this number, 4,261 in your calculator. Divided by 1,000, divided by 10. That'll work out. Okay? That'll work out. Later on, when we're doing these, we're going to have numbers on the top that won't always be ones. So you may be multiplying by some numbers as well, ladies and gentlemen. So because of that, the way I choose to do this, is I take this number and I multiply by everything on the top first. Okay? Which in this case, there is nothing else. They're ones. Then I divide by, but what I do is I take all of the numbers that are on the bottom and I multiply them together. However, if you're going to do that with your calculator will do order of operations. What I mean by that is if you do 4,261 divided by 1,000 times 10, you will get 42.61. It will divide by 1,000, then it will multiply by 10 for you. But if you do 4,261 divided by parenthesis 1,000 times 10, close the parenthesis, it will multiply these two numbers together before you divide by it. If you want to do it that way, that is the only way you can do it. So when you have more than one number on the bottom that you need to divide by, you can either divide by both, perfectly fine, or you can multiply by this number times this one, but they have to be in parentheses. So when we do this, ladies and gentlemen, I think you're going to see we get the number what? Okay. 0.4261 grams. Okay. 0.4261, decagrams. Questions?
No.
Okay. Two things real quick, ladies and gentlemen. Two things real quick before I forget them. Number one, you do not have to put the 0 in front of the decimal point. It would be right or wrong with or without that 0. But people put that 0 there to draw attention to the decimal point. Okay? So please keep that in mind. All right? Number two, this number up here. In science, we don't use commas. Why? Because they can easily be confused with a decimal place. Yes. So you will not see us use commas in a number, ladies and gentlemen, or at least you will not see me use commas in a number. You will occasionally see people do this, though, in science. This is not trying to show you that it is two different numbers. But what it is trying to show you is they will occasionally, maybe not this big, but they will literally leave a space every 3 places to make it easier for you to count how many places there are. Okay? So again, if you want to do that, that is fine. They will leave spaces. They will not use commas, just so you know. Okay? Questions? When you get this, please make sure you put your name on it because there is not a spot on it for your name. There should be more than one page there, but I'm not sure if that's
one
too.
packet, but
Are we done with the notes?
What?
Are we done with those notes?
I think so for now.
There's another one.
What's that?
There's another one.
You want to do the other one, or you want to do ones off the here?
Oh, no.
Okay. I always put in a few too many, it seems like, into the thing in case there's a lot of questions, but since you guys aren't asking questions, I assume this is 120% completely understood, right? What do you mean, no? Then why aren't we asking questions?
I'm slightly confused, but I feel like if I practice it.
Slightly confused. Well, the best way to unconfuse yourself is to actually try doing these instead of just watching me.
You know how to spell this?
Yes, I do.
what?
S-K-A-L.
Wait, what?
E-T-S-K-I.
Okay.
No, it's like, that's how I.
That's how,
All right.
So you had to abbreviate cigarettes before I do that.
In my brain.
Okay, so let's take a look at this, ladies and gentlemen. We're going to show you what you need to do to get credit on here. Okay? Actually, I'm going to show you what you need to do on a test. Let's put it that way. Okay? What's that? You can use your periodic table on any test, on any quiz that I give you this year. Okay? Any test, any quiz I give you this year, you can use that. So that's fine. All right, ladies and gentlemen, so let's take a look at this. Apparently, I didn't open this worksheet up yet. All right. Sorry.
Especially if they have,
All right. Okay. So since number 1 is already done for you, ladies and gentlemen, doesn't make a lot of sense for me to do that for you. So let's take a look at number 2. Okay. Now, the one thing that you are going to need for this, ladies and gentlemen, the one thing you may want to keep your computer open for is this table right here. And I would probably go back a few slides. Let me get this out of the way. I would go back a few slides to this one here. Sorry. Slide number 27. This is what you are going to need to do to find the information to do these problems. So, letter B, first of all, they want you to convert all of these followings to grams. So we're going to grams in all of these. That makes all of these one-step problems if you're going to grams, ladies and gentlemen. So the relationship between grams and centigrams is this. 100 centigrams equals 1 gram. This one right here, ladies and gentlemen. So if you're wondering where I'm getting these numbers from, this is the table that they are all coming off of. Okay? This is the table they are all coming off of. All right, so I need to write that down somewhere, so I'm just going to put it in here. 100 centigrams equals 1 gram. So now I'm going to take my 58 centigrams, and we are going to use this to convert it. Now again, centigrams need to cancel out, so the only way they will cancel out is if they are on the bottom here, because that's the only way these two units will cancel each other out. That means 1 gram goes on the top. The unit that I'm left with is grams. That's what I wanted. 58 divided by 100 is 0.58 grams. Okay? So this is what I would expect you to do. Now, please understand, on a test, this is worth a point. Showing me how you get from one unit to another. Now, if you want to come up with a different way, that's fine, but you got to explain to me then why you would either be dividing or multiplying by 100. And just saying because I need to divide by 100 is not a good enough thing. You would have to explain to me that centigrams are smaller than grams, so therefore we're dividing by 100. You would have to explain to me that grams are bigger than a milligram, and that's why we're dividing by 1,000 in the one above. Or maybe multiplying by 1,000, depending on which way we're going. Okay? And then this gets you a point as well, ladies and gentlemen. And please do not leave off the unit or you lose a point for that. Okay? So you got to tell me the number and the unit. Questions? All right. So here's the easiest thing, or here's the best thing for us to do. You need to practice. You need to work on these. You want to work with a partner sitting next to you or somebody else in the room, go ahead and pull your chair up next to them. You want to work in a bigger group of 3 or 4, you can go in the back and use one of the lab tables. Just slide my alfalfa seeds off to the side for today. All right? You want to work on it on your own. That is completely your choice, ladies and gentlemen. Now, I will be coming back together because we have to give you some information to do the ones on the very back page. Okay? But we'll come back together and talk about that in about 25 minutes or so after you've been practicing this for a while. Go ahead and go to work, ladies and gentlemen. If you have questions, raise your hand. Let me know. I will be happy to come over and assist you.
Because
Their brain, yeah, they didn't have,
your brain isn't
they didn't have
gonna
oxygen to their brain.
That's why, like, when babies are born and they're like suffocating, it's like so weird. That's why they're like.
All right.
Oh, weird.
The very last page, ladies and gentlemen. Okay. To go from milliliters to liters, you should be able to do. You've been doing that conversion earlier in here. Okay? For this one, cubic centimeters to liters. Here's one thing that you need to understand. A cubic centimeter and a milliliter are exactly the same amount of volume. So 1 milliliter of a liquid will occupy 1 centimeter by 1 centimeter by 1 centimeter. They're the same measurement of volume. So that means that we could say 1 cubic centimeter equals 1 milliliter here. So this number, which is 90.4 cubic centimeters, is also 90.4 milliliters. Now convert it. Okay? Now convert it. By the way, there's actually a third way that you will sometimes see this written. One milliliter equals 1 cubic centimeter equals 1 cc. What is a cc? Anybody?
No.
All that doctor talk and you guys don't know what a cc is?
I was talking about Grey's Anatomy. That's not.
And they talk about cc's all the time on Grey's Anatomy. Because a cc, ladies and gentlemen, is a cubic centimeter in the medical field. So in the medical field, when they say give them 10 cc's of something, you're giving the person 10 milliliters. Okay? Also, if you're talking about a motorcycle, an ATV, a snowmobile, the engine size on those things is measured in cc's. 150 cc, 300 cc, 450 cc. That's cubic centimeters. All three of these mean the same thing, just so you know. I don't give you this much because, again, in science, we don't, in chemistry, we don't use it much. Medical field, they do. Okay? But it means the same thing. All right? So, what I want to look at is the ones that are down on the bottom because I think you can handle I think you can handle S and T. The one that may be a little bit difficult for you would be U. And that's because we have to use a trick here. And I'm going to show you the trick that we're going to use. Okay? Now, I want to get from cubic decimeters into liters. That's what I want to go to. Okay. Well, I know if I can get into cubic centimeters, I can get, let me not do that. I don't want to do that to you. Sorry. I could do that. We just talked about that, but I don't have that anywhere written down for you. But 1,000 milliliters equals 1 liter, and 1 centimeter cubed equals 1 milliliter. Okay? So I'm going to use these two things. But first I need to get out of this cubic decimeters and into cubic centimeters. So what we're going to do is we're going to do a little trick here, ladies and gentlemen. 1 decimeter equals 10 centimeters. Okay? I'm giving that to you. It is not on your table directly, but I don't want you to having to set up 2 of these. So I gave you this one fact. Now, where would decimeters have to go, ladies and gentlemen? Bottom. And then 10 centimeters goes on the top, correct? Will decimeters cancel cubic decimeters? This is decimeters cubed. Will they cancel? Not completely. So what I'm going to do, ladies and gentlemen, is I am going to cube this whole conversion factor. Now to do that, what I need to do, if I'm going to cube this whole thing, I have to cube 10 and I have to cube the unit. Okay? So 10 cubed is 1,000. Centimeter cubed is centimeters to the third, correct? Okay, on the bottom is 1. What is 1 cubed? 1. And what is decimeter cubed? So one of the hard parts about this, ladies and gentlemen, is when you use this trick, you have to not only cube the unit, but you have to cube the number. Cubing 1 is not a problem. Stays 1. 1 times 1 times 1 is 1. People forget to cube the number that is not a 1. The 10, the 100, the 1,000, whatever it may be. Okay? So now, ladies and gentlemen, this part right here, this is really 1,000 centimeters cubed, and this is 1 decimeter cubed. Now these cancel out. Okay? Now they cancel out. And next, I can use this one because I'm in centimeters cubed. So 1 centimeter cubed on the bottom, 1 milliliter on top. Centimeters cubed, cancel out here and here. And you've got one more conversion to do, and that's go from milliliters to liters. So what goes on top, what goes on the bottom? Okay, 1,000 milliliters on the bottom, 1 liter on top, or if you say it the other way first, a liter on top over 1,000 milliliters, I'm fine. Okay, so here you're taking 611 times 1,000 divided by what? What do you get? Oh, come on. That's all it is. If you're multiplying by 1,000 and then dividing by 1,000, you're not changing it. In other words, 1 decimeter cubed is equal to a liter. It works out that way. Now your next one will not. Okay? A cubic meter is not the same as a liter. But this one, you're going to do that exact same method here. The exact same thing, except here you're going to use 100 centimeters over 1 meter. Same exact problem. Okay? Questions? All right. What's it? It's already in.